Okay, so this challenge coronavirus problem it really illustrates how quickly a virus can get out of control if the government or the people don't take steps to kind of make sure that they're being safe. It's a really good example of exponential growth. So we're going to start here. It says that we're going to create actually a little side image here. I'm going to say on day 1, we have 2 people. It says there are only 2 people in the beginning of the outbreak. But for every person that has it, they infect 2 more people. So on the next day, each of these people infects 2 more people. So on the first day, there were 2. Now on this day, there's 4 more. So that means a total so far of 6. On the third day, each of these people infects 2 more. And now you have 8. 8 plus 6, now you have 14 total people. Okay? And we could keep going. Now, I'm not going to keep drawing this. I think it's a little bit easier to do a table. So, days and number of cases. Okay, so 1, 2, 3, 4, 5. Let's go all the way to 10. Okay. And we can just kind of transfer some of the information that we found right here. Okay, so on the first day we know there were 2 cases, then on the second day there were 4 new cases, on the third day there were 8 new cases. Let's see, do we notice any kind of pattern going on here from day to day? If you notice an exponential pattern of ×2, you'd be correct, which means on day 4 there's 16 new cases, then 32, 64, 128, 256, 512, and then 1024. Now, this is a really good example. Let's see here. After just 10 days, it went from 2 cases to 1024 cases just on this one day, which means how many total people would be infected after 10 days? So the total would mean we have to add up all of these numbers right here. That would give us the answer. So if you got the 1024, that's an awesome job. That's super impressive. But in order to actually get the answer correct, to find the total, you have to add up all of the cases, not just the cases for day 10. You got to add up the 512 and each of these as well. Now, I have another screen here I'm going to show you. Okay, so here we are. This is a powers of 2 example. So I just created this table, recreated it right here so it's nice and easy to read, okay, after day 1. And I also created a third column for total number of cases. So this basically adds up everything that we have here. So for example, the 6 means everything up here. 14 means these 3. 30 means adding all this up. And so after 10 days, if you add up all of these numbers right here, 1024 plus 512, you get 2046 cases in 10 days. That is extremely, extremely aggressive spread of a virus. Now, that's only 10 days. The second part of the question was, well, how many cases would there be after 30 days? This is, and if you did this, again, I'm very impressed. Okay, after 30 days, here's what would happen. That exponential growth would just kick into high gear. Each day, it's doubling and doubling and doubling. By the 20th day, you have over 1 million cases just on that one day. Then, if you keep doubling, by the time you get to the day 30, you have over 1 billion with a B cases on just the 30th day, which is insane because that's about 1/7 of the entire world population. Now, if we wanted to get the total number of people that were infected, you'd have to add all of these numbers in this column right here. And then you get this right here. 2,147,483,646. Without proper care and without government intervention, if people aren't careful, a virus like the coronavirus can really, really multiply very quickly. And this is a really good example of exponential notation and how quickly that can multiply. And in just 30 days, over 2 billion people could be infected. Right? Hope you guys had fun with these problems. I hope you guys learned a little something and also understand kind of how serious some of these viruses can be. All right? Thanks. Till next time.